Hello everyone, we are back with our chapter that is acid, bases and salts. Previously, we have discovered so far about the physical and the chemical properties of acids and bases. Now, before going further for the types of salts, let's read about the most important term about the acids and bases, that is pH. So let's start it about their strength. The strength of acids and base solutions can be determined on the basis of their hydrogen ion concentration, that is H plus ion concentration. The more the hydrogen ion concentration, the more the solution is acidic in nature. So to determine the H plus ions or the hydrogen ion concentration in a solution, Sorensen, there is a scientist, Sorensen, in 1909 devised a scale which we call it a pH scale, which tells us about this how much acid is stronger, or the basic solution, how much the basic solution is stronger or the weaker in nature, depending upon the hydrogen ion concentrations in them. Right? So here pH, what does actually it means? The P stands for the power. It is taken from the German word potens, which means power, and the H stands for the hydrogen ion concentration, and this is inversely proportional to the concentration of hydrogen ion. That means pH is inversely proportional to the hydrogen ion concentration. That means if the hydrogen ion concentration is more, the pH value will be low. If the pH value is more, the hydrogen concentration value will be low. So to describe the acidic or basic on a scale, he devised a scale according to the numbers, and these numbers are from 0 to 14. Here you can see that the numbers from the 1 to 14 actually, but it is actually from the 0 to 14. At number 7, everything, if the pH of any object is 7, that means the substance will be neutral. For example, pure water, it is a neutral substance. It is neither acidic nor basic in nature. And the acidic solutions of pH 0 to 7, they will considered as the acidic solution, and they are having the pH less than 7. More acidic solution, the lower the pH. Means if the pH is 0.1 and the same molar concentration is there, and the pH of that another substance will be 6, that means the strong acidic will be of 0.1 pH value. Similarly, with the case of bases, the bases are also having the pH more than 7. So more the pH, the higher the basic solution will be more stronger. The 14th pH means the basic solution will be stronger. All the substances having pH more than 7 are basic in nature, or we can say that alkaline in nature, and hence they can easily turn the red litmus to the blue, and the other indicator they will show this thing also. Clear? So there is one more indicator, like universal indicator. It indicates the different colors for the different pH values, right? What it is a mixture of many different indicators. We can say that it is a mixture of dyes which gives different color at different pH values of the entire pH scale. The pH scale is range from 0 to 14. Like the pH of the common substance, it is given here, like 1 molar HCl, it is having 0, and 1 molar NaOH, it is having 14 pH. The pure water, which is neutral, it is having the 7 pH, right? Other than this, the most important thing is the urine is having the 6 pH, soil 5.5, milk 6.4, milk of magnesia, that is also used as an antacid that work against the acid and neutralize effect. Its pH is 10.5. Right? Apple juice is little bit acidic, as it is malic acid is present, so it is 3.8 pH. So the other different pH is already given. The detergent is having 8 to 9 pH present in it. So because of the universal indicators, the common indicator that can tell us the relative strength of acid and bases according to the pH by giving the different colors. Now let's move to the importance of pH in our daily life, right? So pH plays an important role in many activities of everyday life. For example, first example, let's take as the digestive system. In our digestive system, the stomach it produces HCl, dilute hydrochloric acid, which help in digesting the food easily without harming the stomach. But if its concentration will increases due to various responses, like if you eat excessively, overeating, right? For to neutralize it, to digest that, the stomach produces more amount of HCl in our body, right? So what we do, if the excess acid is produced in our stomach, it goes indigestion. We are not able to digest our food properly, and which produces pain as well as the irritation, right? To cure this ingestion and get rid of pain, what we do, we use antacids, which again work against these acids. For example, antacids are being basic in nature, they can neutralize the effect of HCl. So the two other antacids, which is milk of magnesia, which we have already learnt about it, that is MgOH whole twice, right? And the sodium hydrogen carbonate, NaHCO3. These counteract or neutralize the acid produced in our stomach and give us relief to the person who is feeling the indigestion. The second, the pH change is the cause of tooth decay also, right? It is because when we eat food containing sugar, right, so the bacteria present in our mouth break down that sugar and produces acid from it. For example, lactic acid, right? This lactic acid formed in our mouth after a sugary food we have eaten, right? So this lactic acid, what it does, it lower the pH of our tooth, making it acidic. Lower the pH of our mouth, making it acidic, and tooth decay starts when the pH of acid formed in the mouth that falls below 5.5. This is because the acid decomposes strong enough to attack the enamel of our teeth and corrode it, right? So what is the best way to prevent this? The best way to prevent this is to wash our mouth after eating food and doing brush with some alkaline toothpaste. So if you read on the toothpaste cover, that you will be able to see that the toothpaste is containing some of they are basic in nature and they can neutralize the effect. Similarly, the pH of soil pH that is necessary for the plant growth, right? It is also helping, it is kind of, you can say that plants mechanism or sensitive to the pH, as most of the plants grow best when the pH is close to the 7. If it is less than 7, the soil will become acidic, and if it is more than 7, then the soil become basic in nature. So if the soil is too acidic, what we have to do, we have to treat it with the material like calcium oxide or the slake lime, calcium hydroxide, like calcium carbonate also used, because these are all basic in nature, and being basic in nature, they can neutralize the effect of the acidic that is present in your soil. Similarly, if the soil is more basic, then what we have to do, we have to check, firstly we have to check the pH, if it is basic or if it is acidic. If the pH soil of pH is too alkaline, then to reduce its alkalinity, what we have to do, we have to add the organic matter in it. Organic matter being acidic in nature, what is it? It contains the acidic material, so it can neutralize the effect of basic component that increases the pH of the soil. Next, the plants and animal sensitivity regarding the pH. The pH change and the survival of animal, we can say that pH change and the survival of how we can take the example of like aquatic animals. They can survive in lake on water within a narrow pH range, and if the pH of the rain along with the pollutants, it can reduce to the 5.6, if it becomes lower, then it will become the acidic rain, acid rain or the acidic rain. This rain, what too much acid in the rain can lower the pH of the lake or what or river. Why? Because rain ultimately falls in the river or the soil or the river lake water, right? So it lowers the pH to such an extent that the survival of aquatic animals becomes difficult. The high acidity of lake water or river water can kill the aquatic animals. So calcium carbonate is often added to the acidic lake water to neutralize the acid that comes from the acid rain. This prevents the fish in the lake from being killed, and also it prevents the aquatic plants also. Next, the self-defense by animals and plants through chemical warfare. That means when some animal or a plant, if you come in contact with them, so to prevent themselves, what they do, they bite you. For example, wasp, right? Wasp bites you, and if you're moving through an ant, it touch them, so they also bites you. So some of the like wasp, sting has the alkaline liquid. So when wasp bites you, everybody near the area, you can say that you just apply the pickle over that area where wasp bites. Why? The pickle is having some acidic in nature, right? Acid substances present in them. So to reduce that, the alkalinity solution of the wasp, so we can put that pickle over that area, right? Similarly, when ant bite, it forms the formic as well as the methanoic acid, and it causes burning pain. So in that area, we can rub some baking soda, like mild base, so that it cannot get affected our skin. Similarly, there is one more plant that we call it a nettle plant leaves. If you come in contact with these nettle plant leaves, they inject a methanoic acid into your skin, and this can be reduced by some dock plant near it, or we can apply the baking soda also to neutralize it by rubbing it to neutralize the effect of the